Hi. You can get this book off of www.survivalebooks.com. Alright, this is your United States Army Combined Army Support Command Wheeled Vehicles Electrical System Part 1, Subcourse number OD1002, U.S. Army Warning Center of Armidine Proving Grounds, 5 credit hours. Lesson 1. Introduction to Automotive Electricity. Describe fundamentals of alternating circuit. Direct current electricity is applied to automotive equipment. Conditions. Given information on the history and the theory of electricity, characteristics of conductors, insulators, current, voltage, resistance, their relation to AC, DC, magnetism, induction, electrical symbols, circuits, and common circuit defects. Lesson 2. Automotive batteries. Describe the construction, operation, maintenance of automotive batteries. Give the information on the construction, operation, rating of batteries, method, connection, maintenance procedures. Lesson 3. Fundamental electrical test equipment. Describe the purpose, construction, operation, electrical test equipment. Give information on voltmeters, ammeters, ohmmeters, low voltage circuit testers, millimeters, and simplified test equipment for internal combustion engines. And then it shows the table of contents with a list administrative instructions. Alright, introduction. Electrical system military wheeled vehicles are well designed, constructed with few exemptions. They must be like systems used on civilian type vehicle. The biggest difference for the 24 volt system are used in military vehicles. 6 and 12 volt systems are in civilian types. All electrical systems, most military vehicles, are waterproof. Although these systems well made, still give trouble, and they are systems that most wheeled vehicles repair understand the least. On your jobs is the maintenance of these systems while this is not difficult, it does take some know-how. The subcourse familiarize yourself with these systems, provide you with know-how you need. Lesson 1. Introduction to Automotive Electricity. Tasks. Describe fundamentals of AC, DC, electricity applied automotive equipment. Given information and history of the theory of electricity, characteristics on conductors, insulators, current, voltage, resistance, relationship, AC, DC, magnetism, induction, electrical symbol, and circuits, common circuit defects, standards, reference TM9 8000, learning event 1. Describe principles of electricity and magnetism introduction. During the past 100 years, electricity became most important to the man each year went by. Today, in our homes, we depend on light and heat and music. It provides more power, operated water pumps, tools, kitchen appliances, and many other household items outside the home. We also depend on electricity for many things. Family car is a good example, used for electricity for lights, music, heat, and to make engines run. Most of the time, we simply fly with a switch for the electrical work for us. In housing, you use the switch to turn on lights and radio. Use the same thing in your car. Electricity does not do the work. Suppose when you do not move the switch, usually need to help for repair. Use wheeled vehicle mechanic as the repair who will be called upon. Electrical system army vehicles do not work. You need to find out what is wrong first, then correct the trouble. Each of us usually realize how much do we depend on electricity day-to-day activity. Without it, there would be no electrical lights, heat, refrigeration, and so forth. Military vehicle will work on most of the electricity for many purposes, such as ignition lights, blower fans, and so forth. Therefore, it is easy to see that the wheeled vehicle mechanic must have the working knowledge of the electrical circuits to keep the equipment in good operation condition. To do the job, you will have to find and know the electricity, how it is used, and how electricity items work. The lesson gives the information to understand the electricity and how it can be made to do this work for us. Common knowledge of electricity. To begin with, a level to review the things commonly known about electricity. Normally, closing a switch always takes to make it work. It's available several sources such as flashlight, battery storage batteries, like ones used in the cars, generators ranging from hydroelectricity plants to car generators. When electricity can cause shock sensation if you touch it or a body. We also know that the amount of electricity increases, the shock will feel gets worse. It can do the work. Today is one of the most important sources of energy. We know that the wires and other connections are needed to be between the source of electricity and their appliance to be operated. Scope of this lesson. Complete study of electricity is a wide and complicated field. Even though lots of questions are understand, there is still a lot to learn. The lesson is not designed to teach you that there is too much. There is to know about. Tests you all there is to know about the subject. The informational lesson is able to understand automotive electricity, and what it is supposed to do, and how does it do it, and how to determine what's wrong if there's a problem. Alright, historical milestones. The word electricity comes from the Greek word electron, which means amber. More than 25,000 years ago, the thales of the famous Greek found out electricity existed. They noticed that after he rubbed pieces of amber in the wool cloth, the amber would attract lightweight items like straw, dust, dirt, and feathers and lint. This is because the amber had become electrically charged. The Thales knew that nothing about the electricity, so he thought what this would happen only with the amber. In 1973, the French scientist named Dufay found out that this piece of glass was rubbed in with a cat's fur. The glass and the cat fur would become charged and electrified. He found out that the charged glass would attract certain things that fur would repel and push away. From this equipment, he correctly decided that there was two kinds of electricity that were direct and opposite. Benjamin Franklin decided two kinds of electricity should be named positive and negative. They are commonly referred to as plus and minus, as shown in plus and minus. Plus for plus, with a plus sign, refer to one kind of electrical, negative minus, and negative subtraction sign for the opposite charge. Like charges repel each other and like charges attract. If those with two atoms have a positive charge repel and push away each other, the same action occurs if the atom has negative atoms. On the other hand, if you will have one item with a positive charge and another item will have negative charge, this will attract and pull together. For many years, they believed that only such things as glass, amber, silk, ears, cat's fur could be electrified and charged. We now know, however, that under certain conditions, all substances can be electrified. Alright, matter and the atom. The mystery of the electrification of the positive and the negative charge was finally solved with the studying of the construction of the matter. Matter is any substance with the weight and they occupy the space. Example of the matter, air with the breathe, the water, cars, clothing, and so forth. To give an idea of what the electricity really is, you will be able to predict the action of the automotive electricity circuits. You will need to briefly look at the construction of matter. Imagine you come to take some of the matter, such as a rock, break it down into the smallest particles can exist with the original substance that you started with. These tiny particles are known as molecules. Actually, you won't be able to do this, so you continue to crush the rock, and you would finally end up with the particles of dust. Just like one small dust particles would contain thousands of molecules. Scientists have discovered that molecules contain one or more building blocks known as atoms. Each atom is an element. These are about 100 different kinds of atoms or elements. So are metal, such as copper, iron, and gold. Other non-metallic, such as oxygen, hydrogen, sulfur. While the element by itself is matter, different kinds of matters are formed, and by mixing elements of these two or more elements are mixed, we get matter known as a compound. For instance, molecule water is formed with two hydrogen atoms and joined with one oxygen atom. Therefore, water is a compound. The secret of electrification was not discovered until scientists finally discovered that atoms are made up of three smaller particles. Particles: electron, protons, neutrons. The proton has a positive charge, electron has a negative charge, neutron has a neutral or have no charge. Figure 1 shows that we believe the atoms look like. Figure 1 shows the copper atom. Example of these, what we will use is one element of the copper. Imagine having a magnifying with a glass magnifying the atom so that it appears 100 million times larger than its actual size. This makes a look at about 1 inch in diameter. You can now easily see the atom has a central body and a nucleus. You can also see there's 20 smaller particles with electron rapidly circling around the molecules, one moving in a different path. Now imagine that magnifying the copper atom even more so that only the nucleus fills the viewing area. The nucleus now looks like a bunch of grapes and actually consists of 64 particles bound and tightly together, 29 for the protons, 35 for the neutrons. All items of the one element are exactly alike. They have the same number of electrons, protons, and neutrons. They all have the same size and all the weight is the same. On the other hand, the atoms from different elements are completely different. The atoms of each element contain an equal number of electrons and protons. Recall that the copper atom contains 29 electrons, 29 protons. Figure 2 shows a free electron, the outermost shell, and the free electron. Now let's go back with the magnifying glass with reduce its power so that we can see several atoms copied to the viewing area. You can now see some of the electrons move in the outer circle, but the atoms do not always stay in the same atom. Instead of the moving haphazardly from atom to atom, knowing that they are now is known as free electrons. They are ones of the most interested of our body of the automatic electricity. As some of the free electrons move out of their orbits, atoms will move with the proton, but it does not electron. Some of the proton have positive charge that give the atom a positive charge. If the free electrons move with the atom, they already threw enough electrons. The atom will be negatively charged since there will be a surplus action. Electrons negatively charged body repels. Electron positively charged body attracts the neutrons. Electron motion. Automotive electricity, we are interested in the movement of electron through an item such as wire. Some of the movement of electron known as electric current, just as flow of the wire stream is known as current. When there is surplus of electron one end of the wire, shortage of the electrons at the other, the electrons will flow in the surplus to the shortage. The surplus to the electron is the negative charge, shortage positive charge. Electron current flows from negative to positive. Figure 3. Electron motion shows the negative excess of the excess of the electrons. The electron flow through the control. Positive lack of electrons. When the electrons leave the negative source, the same electron does not just speed through the wire. Instead, it strikes the end, and another electron knocks it loose from its atom, looses an electron, then strikes another, knocking it free, and one electron knocks another loose. It repels once and knocked out. The curve of the chain reaction through the entire length of the wire. The illustrator, imagine you have filled pipe filled with marbles from one end to end. If you push a marble in one end of the pipe, the one marble will pop out of the opposite end. As soon as the marble presses with the column marbles, the movement with the transmitted all the way through the pipe. The pipe is comparable to the wire with the marbles to the electron. Electrostatics, magnetism. We now take this mechanical energy to crank the engine, yet done with supplying electrical energy with the start of the motor of the vehicle battery, also known as using mechanical energy to drive the generator. We are able to produce electricity. Magnetism, connecting the link between the mechanical energy, electrical energy. Understanding why, it must first learn some basic facts about magnetism. Magnetism is a visible force that attracts iron and steel. The first known particular type of the stone called magnesite is natural magnet. And magnesite, it was first used as a compass to tell the direction sailors in ocean travel to an unfamiliar country. This was possible to cover the piece of magnet suspended with the free to rotate will turn with it as the points for the Earth, the magnetic pole and south poles open end always points to the north, and so called the North Pole with the opposite end called the South Pole. Pieces of natural magnets taken from the Earth like have value now. Better magnets can be made with the iron and steel artificial means. Magnets are made with soft iron known as temporary magnets because they are loose fit. Magnetism made from steel known as permanent magnets because they stay magnetized for a long time. Permanent magnets, most of them are familiar with the bar and horseshoe shaped thing kinds. Let's discuss the fewer experiments, some permanent magnets to gain some knowledge and visible force they possess. If a bar magnet is suspended with a thread, it will swing to the north and south direction over the end of the points of the earth magnet poles. Like magnetic, the end of the magnet toward the northern is known as the North Pole, and the end is known as the South Pole. Today, the second bar magnet moves from the North Pole toward the North Pole with the suspended magnet. As we can see, the suspended magnet moves always from the second magnet. Likewise, the South Poles move the closer together. The suspended magnet will move away. Therefore, the magnetic poles will likely to repel each other. Now, let's move to the South Pole with the second bar magnet toward the North Pole with the suspended magnet. Instead of moving away that it did before, the suspended magnet now moves toward the second magnet. In fact, always move the North and South Poles over the magnets come in contact. They stick together and it takes considerable force to pull them apart. Like this experiment, they prove that unlikely magnetic poles to attach each other. Surrounding space around the magnet is affected with the invisible force known as the magnetic field. The magnetic field is demonstrated with a spring. Some of the iron fillings of the piece of paper that has been placed at the table top of the bar magnet has dropped into the center of the paper. Of course, large number of the fillings immediately attracted and moved about by the magnet. Figure 4 shows the magnetic field. In the tabletop, gently tap the filings would move about, arranging themselves with definite patterns of the lines of magnet. Patterns should determine the force of magnet field around the magnet. Notice the lines are clearly near the magnet and gets less distinctive farther away. This is because the magnetic field is stronger near the magnet and gets weaker in the distance. Figure 5. Magnetic lines of force. Lines formed with the magnet known as lines of force. Actually, lines of force extend all the way around the magnet instead of the flat plane shown in the filings of the paper. Shown in the line drawings and views of the bar magnet shown here. Note that arrowheads have been placed on lines of force indicating direction. Also, note the arrows indicate lines of force in the north and enter the North Pole and entering the South Pole. Unlike poles, It can be proved that the lines of force do have direction movement of the two magnets iron filling with the magnets of the iron fillings unlike poles facing. Now the lines of the force over the unlike poles combined with the increase of the strength of the magnetic field between two magnets indicate lines of force between the unlike poles of the field flow in the same direction. Like poles. Now position two magnets like poles facing. Notice that the iron fillings of the magnetic field do not mix. Instead, they turn away each other, indicating that they are moving in the opposite direction, repelling each other. Alright, induction. By now you may be thinking of what does the magnetic force do with the electricity with the give of the manner of the considerization, find out the connection, how it was used. Figure 8 shows electromagnetism. First you think about the experiment easily done. Path of the wire, hole of the center of the piece of the cardboard level the spring iron fillings around the net wire. Now connect the wire to the battery, conduct the current with the tap gently with the cardboard with the filings. Will then circle around the wires to prove that the magnetic field with the circles of the wires as known as the magnetic field created with electricity shown an experiment is known as electromagnetism. Carry the experiment or farther prove the lines of force with a wire having direction is effective with the direction of the current flow. By placing a compass at various points of the magnetic field around the wire. Notice that the compass with the needle always align with the lines of force for the North Pole with the needle pointing in the direction of the magnetic field. Now reverse the wire's battery terminals current flows to the opposite direction of the North Pole compass needle will also reverse direction, proving the reverse direction of the current and the wire reverses the direction of the magnetic field. Then it shows figure 9 shows lines of force in a coil. Electromagnet may be stronger with the increase of the amount of the current through the conductor, with the weaker with the decrease of the current with the concentrated, with the making the magnetic field strong. One over the winding conductors in the coil with the most turn with the coil with the stronger than the magnetic field in the area. Often the core is placed inside of the coil to make the magnetic field even stronger than possible, but the lines of force travel the easier they do through air. Repelling and attracting force of the magnetic field of electromagnets are used with electromotors, other devices of magnetic jobs, the automotive vehicle with the operating range, cranking the engine to operate, opening and closing of some of the contact points on a relay switch. Now let's see how the machine force can be used with creating electrical current using a horseshoe magnet conductor such as copper wire, sensitive current indicating meter such as a galvanometer, and demonstrate this. Figure 10 shows electromagnetic induction of the wire ends and connecting the meter to the conductor, move the conductor downward between the poles of the magnet. When this is done, the indicating needle of the will momentarily move the way of the zero, indicating the surge of the current flow of the conductor is held still in the magnet field with the meter in the needle will move at zero, indicating that there is no current flowing through in the conductor. This shows the magnetic field causing free electrons to move away from when the conductor is in motion, moving across lines of force. The amount of voltage and resulting current flow induced into the conductor can be increased with several from the methods. The faster the conductor moves across the line of force, the greater the voltage. Increase the strength of the magnetic field will increase the voltage. Another method of increasing the voltage is to wind the conductor into a coil, and several turns of the coil can be passed through a magnetic field at one time. As you can see, with the electricity of the conductor, we must have the magnetic field of the motion. With the automotive generators, mechanical energy with the engine of the used to supply the motion. On some of the generators, conductor is moved with the stationary magnetic field of the wall. On other magnetic field is moved with the conductor is stationary. Induction principle, also used as transformer. A transformer is an electrical device that is used for stepping up and stepping down electrical voltage. Ignition coil of the automotive vehicle, there's actually a transformer step to 12 to 24 volt battery volted up several thousands of volts needed to ignite the fuel. Make sure the following paragraphs will discuss the construction and operation of the transformer. A simple transformer often contains an iron core consists of two coils of wire. One coil is actually electromagnetic and is carried in primary winding. The second coil is a secondary winding. If the primary winding connected to the battery, the current will flow over the winding, causing the magnetic field to build up around the coil. The fields build up, the line of force is moved outward, connecting across the coils, and secondary winding will have the voltage induced and resolve the lines of force acting, cutting across the coils. Now, if the ends of the secondary winding conductor will connect to the complete circle, the current will flow until the induced voltage drops. When the primary winding is disconnected from battery, the magnetic lines of force will collapse and disappear. But that happens with the line of force move rapidly inward toward the primary winding. Again, moving lines of force cut the coils of the secondary winding, inducing the voltage. The time of the lines moving in the opposite direction, so inducing the voltage cut of the current flow in the opposite direction. Weathering event 2. Describe fundamental electrical circuits and symbols. Conductors. Atoms of different elements are not alike. Electric currents will flow through some of the materials easily than others. Particularly, no electrons will flow with the current flow with the material easily, but the material is called the conductor. A good conductor is a material large enough to free electrons. All metals of the conductors of electricity are better conductors than others. Example of the good conductors are silver, copper, and aluminum. Silver is better conductor than copper, but copper is more widely used because it's cheaper. Some of them, since aluminum is light, is cheaper the conductor, while the weight of it is major consideration. The ability of the material to conduct electricity also depends on size. The greater in diameter, the shorter in length, the better in conduct. The conductor may be in forms of bars, tubes, and sheets. Most common for them form is wire. Many sizes of the UIs use them fine like hair-like wire sensitive measuring instrument. A large bare bar-like will be used for carrying high current with a power generator plants. Most wire conductors then that you will be working with automotive vehicle with stranded wires. Strand wire consists of many small wires twisted together to make one conductor. This makes the very flexible so that they've been fitted around the vehicle components without breaking. Insulator. The material has so free electrons have blocks electron flow that's called insulator. No material is a perfect insulator, but some of the materials use poor conductors that all of the particular purpose of all classified in insulators. Example of insulators are porcelain, glass, air, rubber, oil, bakelite, and certain kinds of enamel and varnish. Insulators are used to make sure flow of electrons do not stray off the path that has been provided by the conductors. Example of these insulators use to anchor overhead electrical lines, utility poles. Insulators block the electron and prevent them from flowing into the pole into the ground. In an automotive vehicle, the insulator must be used to keep the electrons current in the proper path. The conductor is covered with the insulating material with the rubber, cotton, plastic, enamel, and hard materials as fiberboard, backlight, and use the ignition system for switches, and when parts mounted securely with a rigid insulator. Current. Electrical current, like the flow of the water, can be measured. Water flowing in the pipe is measured by a number of the gallons of water per flow per minute. Electric current is measured in units known as amperes. It takes more than 6 billion electrons to move passing the given point in 1 second to make up 1 ampere. A device for the ammeter is used to measure amperes. 1 amp may sound like a lot in an automotive electrical circuit. It is considered a rather small amount of current. So some lights may require 1 ampere and starter motor requires 100 amperes or more. Voltage. As we said, the electron flow of the current is called the electron unbalance. In other words, when one end of the conductor positive charge, the other end is negative charge, electrons move to the positive end. The greater the difference for the amount of the electrons opposite end of the wire, the greater the pressure will be the pushing the electron through the wire. The pressure is known as potential difference or voltage. Voltage affects the electrical current wire compared with the pressure and effect of the water flowing through the pipe. The water pressure increases the water pipe, the greater the volume of the water will flow in the given period. If the voltage electrical circuit is increased, the greater number of the electrons will move with the move more current will flow. Voltage is measured with a voltmeter, which will be covered in detail later. Heart resistance. When the voltage forward of the current flow of the wire of the electron meets resistance. Resistance is caused by the friction of the electron bumping into the atom. The rubber fingertips caused by the table of the friction caused by the heat of the move of the fingertips faster. The heat becomes greater. Likewise, the electron flow of the wire caused by the heat. If the voltage increases, the current flow of the amount of the heat are increased, then the current flow will increase enough that the wire may become hot enough to literally burn up. Heating action. Current flow is one of the greatest use of electricity. For example, let's show the look of the light bulb. The bulb with the containment of the filament made with a material that has a lot of resistance for the current flow can be withstand extreme heat. The filaments are ended with the contact with the two contents base of the bulb, usually a metal part with the base surface, and one contact with the filament is then enclosed with the glass, and most of the air is moved. It becomes air gets in the filament, it will burn up easily. Voltage of the battery, other strip of the ply with the two contact with the base of the bulb, with the current with the load of the filament causing the white hot while producing the light. The bulb with the functions properly with the material and the filament side of the filament, but the amount of voltage supplied must be carefully balanced for the just correct amount of the current will flow. If the current flow is too small, the filament will not get heated enough, the bulb will not glow brightly. If the current flow is too great, the filament will burn up. Sometimes a special part known as a resistor is placed in electrical circuitry to reduce the current flow. The action of resistor compared with the restricting action of the water valve with the faucet opening the valve to make will will cause more water to flow because they will be less resistant to the flow of the water. Likewise, reducing the resistance of the electrical circuit will cause more electrical current to flow. Resistors usually made of carbon and special wire, with some of the resistors fixed that they are made so that you cannot change the resistor as you can flow the faucet and water system. Resistors that you can adjust known as variable resistors, rheostats. Rheostat usually as a movable contact which can move along the length of the resistor, moving the contact, change the effective length of the resistor, the greater distance the current travel to get through the resistor, the greater resistance of the rheostat. Non-resistance of the resistor or any other conductor offers of the current flow is measured in ohms. The material 1 ohm of the resistance when 1 volt of pressure will force 1 ampere of current flowing through it. Resistance is measured with an ohm meter, will be covered with later. Relationship quantity of electrical circuit. There is a definite relationship between the voltage, resistance, and amperage that must be considered with maintaining automotive electrical system. For example, the light bulb, you can see whether or not the bulb works. It should depend on the amount of the current is flowing through the current circuit. From our study up to now, you can see that the change in either the amount of voltage among the resistance will change with the amount of current flowing in the circuit. Here are some facts that change with the voltage, resistance, and amperage that should remember. The voltage in the circuit is made higher, but the resistance remains the same. The amperage current will also get higher. The reverse is also true, with less voltage will also cause less amperage. And more resistance put in the electrical circuit, the current is reduced, whereas the less resistance allowed the more current to flow. Resistance can be changed with the changing the length of the diameter of wire by using a rheostat, by using different sizes of fixed resistors. Alright, your alternating current. Electricity comes from the home over the operating lights of the refrigerator, set forth with the alternating current AC, given the name of because of the electron moved through the wire first one direction, and then the opposite. Since the current flows with the negative of the surplus electron to the positive of the shortage of electron, the generation plant producing an alternating current must be periodically changing electrical charges. In this manner, the electron causes move back and forth, and the current circuit is instead constant stream moving in one direction only. The case could be illustrated with comparing AC with the swinging of the pendulum over the clock. Current, like with the pendulum, starts at one extreme part of the right or left, very slowly builds the fastest speed of the amount of 1/2 of its travel. The speed begins with the fall out until it comes to a complete stop, just an instant with the current swinging with the opposite direction. AC is defined by the current with the constant building up, the falling off, periodically changing direction. When electron flow returns same point with the start of the just pendulum completes swinging and fro with the complete with one cycle, with the number of the cycles that occur each of the second is known with the frequency of the current. The current supplied with your vehicle with the country has a frequency of 60 cycles per second. Lately, the term hertz is often used instead of cycles. So remember that 60 hertz AC and 60 cycle AC mean the same thing. Direct current, electrical current with one direction with a direct current, but the direct current is commonly either the short one with the DC, but the batteries cannot reverse electrical charge. They must be done with the produced to AC, so they always supply DC. Since automotive vehicles use batteries, most of the electrical circuits will be working using DC. Automotive electricity sometimes favors the problem of changing AC to DC. For this instance, the vehicle is equipped with the AC generator. The current cannot be used to charge the vehicle battery. In this case, the AC must be changed to DC. Parts called rectifiers or diodes used to change AC to DC. Rectifiers work in one way. Check for the valve of the water system. The current flow through the check valve of the rectifier in one direction, but the flow of the block is blocked in the opposite direction. Rectifier is made with the material that constructed such man with the atoms of electrons moving into one direction, not the other. Symbols. Automotive repair manuals several methods to prevent information that you need to repair electrical system. For instance, the information presented with the written words, but a lot presented through drawings, such as use of symbols. A symbol signify a feature. A figure stands for something else. Symbols, especially with electricity, so that they can be used and show many things actually invisible. Before you can read and obtain the needed information from electrical drawings, schematic drawings, you must know the meaning of the symbols that are used. Let's take a look at some of the common symbols used in the schematic diagram automotive electrical circuit. Alright, your positive and negative symbol with the short and long dash shows a multi-cell. Your winding shows the coil electromagnetic. Your two parallel lines with a show a condenser, capacitor, generator, circle, and ground, a upside down line pyramid. Ammeter shows a circle with an A in it. V meter, a circle with a V meter. Lamp shows your coil inside the circle. Rectifier, a diode, a filled in triangle to a line with a line, a resistor, a zigzag, a drum, a variable resistor. Shows a arrow arrow shorted to the resistor. Switch in opening in position shows a break and a T. Switch in closed position, on position. Transformer, 2 windings put parallel next to each other. Wires crossed, not connected, cover with an O. Wires crossed, connected, cover with a dot. Alright, type of circuits. Electrical circuits can be laid in series, parallel. Troubled electrical circuits you must be able to identify and lay out, understand current flows in circuits. Figure 12 shows a series circuit, batteries, and lamps. First, let's take a series circuit with a good example of the circuit of the series of the connected with the Christmas tree light. Can you recall time with all the bulbs light set quick and be working because one bulb burned out? This is what happens when a series circuit is used. The reason for all the lights can be easily explained with the schematic drawing diagram of the light set. Now this is one wire connected with each of the between the bulb following the electrical path. The current passing must flow with the power source of the first bulb through the bulb filament to the second next bulb through the filament and so forth in order to get back to the power source. An electrical path broken at any point with no current will flow with the lights will go out. This happens with the filament. One of the bulbs burn out. Why breaks in the circuit with the same effect turning on the switch. Then sums up that we can say that the circuit paths number of items connected together in such a manner that the current has only one path of flow. Figure 13 shows a parallel circuit. The parallel circuit is more one path of current to flow. This is the kind of circuit that bulbs string Christmas tree lights connected together by 2 or more wires. Note that each of the bulbs provides a separate path of the current flow. If one bulb burns out, though it will not affect the others. Parallel circuit is most commonly used in automotive electricity. And then you have your series parallel circuit. The series parallel circuit is combined here with the parallel circuit. This is illustrated by a 3-bulb circuit. Here, the all current flow of the circuit must go through bulb 1. This is only one path there has in this series of paths circuit. But on the other side of the bulb 1, the electrical path divides. The pattern current flows from bulb 2 to the remainder bulb 3. The path joins again, forming a single path to the power source of the divided paths through the bulbs 2 and 3 are parallel part of the circuit. Electric circuit defects. Circuits described beyond being ground and shorted, opening and having a high resistance connection. The terms refer to conditions exist for the circuit, usually desirable defect. Let's go in these terms with more detail. We'll graph the full meaning of each. The grounded circuit is when defective insulation allows the conduct such a wire to touch the vehicle frame. The probable cause must actual electric fires allow automotive vehicles. In automotive circuit, only one insulated wire is to the battery is used. The bottom one battery terminal is used with negative and connected with the vehicle frame by a ground cable. Frame serves as one conductor while the switch is closed with the current flow with the negative terminal of the battery through the frame to the bulb through the insulated wire. Light switch to the positive terminal of the battery. Now let's imagine insulators wear off, exposing the bare spot of the wire between the light and the switch and the bulb. But further imagine the exposed wire such that the touch of the frame. Battery current now flows from the frame and touching the wire through the switch, backing to the battery. Before the high resistance of the bulb preventing the large amount of the current will from flowing, which of the wire grounded frame of the current bypass the bulb. Circuit now has very little resistance. As a result of much of the current flow through the wire will get hot enough to melt and set fire to nearby flammable objects. A short circuit occurs when the 2 exposed wire touch. This will let the current flow in the circuit both the wire with enough of the switch closed only in one direction. Can realize the result of the defect. You will imagine you can cause a short circuit between the wires and the tail of the top lights. Tail light switch to turn on the battery current with the frame divided the flow of both of the bolt lights and to join from one path of the short circuit. So both lights are burning even though the stop light should not be. When opening a circuit, the exit no current flow. For example, the light circuit is open when switch is off. Is open or open when the wire conductor is broken. When the bolt filament is burned out, open circuit occurs and circuit is in the good when you turn off the switch. The other conditions are defect is a bad circuit. A high resistance connection is usually resolved with the corrosion of the battery post loose of the wire. The terminal frayed wire has some but not all the strands of wire broken. High resistance current reduces the amount of current flowing and the circuit cannot work as should. Light circuit, for instance, a bulb filament would now glow brightly as it should. Practice exercise, and then that was lesson 1. Lesson 2, moving on to automotive batteries.